All right, look, I'm going to tell you something strange, and I mean genuinely strange. The kind of strange where halfway through you'll think I've lost my mind, but I haven't. This is what the physics says. This is what the equations demand, and the equations don't care whether you find them comfortable. March 1955, Albert Einstein gets a letter. His oldest friend in the world, a man named Michel Besso, has died. Now, you have to understand something about Besso. This wasn't just some acquaintance. Einstein had known this man for over 50 years. 50 years. Besso was the guy Einstein talked to in the weeks before special relativity crystallized. The sounding board, the one person who could keep up with the thinking while it was still half-formed and crazy-sounding. When Einstein published that 1905 paper, the one that changed everything, the one that told us time and space aren't what we thought they were, he thanked exactly one person, Michel Besso. So Besso dies on March 15th, and Einstein, who is 76 years old and knows he doesn't have long himself, writes to Besso's family. Now, what do you write when your best friend dies? What do you say to his family? You say you're sorry. You say he was a wonderful man. You say he'll be missed. You say something warm, something human, something that acknowledges the terrible weight of loss. Einstein didn't write that. Einstein wrote this. Michel has preceded me a little in leaving this strange world. This means nothing. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Read that again. The distinction between past, present, and future is only a stubbornly persistent illusion. He's not being poetic. He's not offering spiritual comfort. He's not talking about heaven or the afterlife or the soul. He's stating what the physics requires. And here's the thing. Here's the thing that's going to twist your brain into knots. He was right. The physics actually says this. The equations actually demand it. Einstein died 5 weeks after writing that letter. 5 weeks. Whatever the physics says about what happened next, the letter remains. And the physics it rests on has not been overturned in the 70 years since. So, let's talk about what the physics actually says, because it says something that contradicts everything you have ever experienced. Here's something that should bother you. It bothered me when I first understood it, and it still bothers me now, even though I know it's true. Every fundamental equation in physics is completely indifferent to the direction of time. I mean completely indifferent. The equations don't know which way is forward. Take Newton's laws of motion. You learn them in high school. Force equals mass times acceleration. Objects in motion stay in motion. All that good stuff. Run those equations forward in time. They work perfectly. Run them backward in time. They work exactly the same way. A ball goes up and comes down. Film it. Play the film backward and a ball goes down and comes up. The mathematics doesn't complain. Both directions are equally valid solutions to the equations. Same thing with Maxwell's equations for electromagnetism. Same thing with Schrödinger's equation in quantum mechanics. Same thing with Einstein's own field equations for general relativity. At the deepest level of the mathematics, at the level of particles, fields, forces, and space-time geometry, time has no arrow. Run any fundamental equation backward and nothing breaks. The physics works just as well with time flowing from future to past as it does from past to future. Now wait a minute, you say. Wait just a minute, that can't be right. Cups shatter, they don't unshatter. Fires burn, they don't unburn. People age, they don't get younger. Time obviously has a direction. Yes, you're right, but here's the trick. Here's where it gets interesting. The thing that gives time a direction isn't fundamental physics, it's statistics. Only one law appears to give time an arrow. The second law of thermodynamics. Entropy increases, disorder grows. But the second law is not a fundamental law, it's a statistical law. It describes what happens when you have large collections of particles, billions and billions of them, and you ask what's most probable. An egg can unscramble. There's no law of physics that forbids it. Every individual particle interaction is reversible. It's just that the probability of all those particles spontaneously arranging themselves back into an egg is so astronomically small that it never happens in practice. At the level of individual particles and fields, every single interaction is reversible. Time has no preferred direction in the fundamental physics. The directionality you experience, that absolute unquestionable feeling that the past is gone and the future hasn't arrived yet, is not written into the deep equations of the universe. That's not philosophy. That's not interpretation. That's what the mathematics says. And it changes everything about what it means for something to be over. 1905, Einstein publishes Special Relativity, and he shows something absolutely bizarre about time. Two observers moving at different velocities relative to each other do not experience the same passage of time. Let me say that again because it sounds crazy the first time you hear it. If you're sitting still and I'm flying past you at high speed, time passes differently for us. Not metaphorically, not philosophically, physically. A clock on a fast-moving spacecraft ticks slower than a clock on the ground, not because something's wrong with the clock, not because the mechanism is affected by the motion, because time itself passes at a different rate for the moving clock. The slowing is real. It is physical. It is not a measurement error. It is not a perceptual trick. Time is not a river flowing at the same rate for everything in it. Time is elastic, stretched and compressed by velocity, by gravity, by the geometry of the spacetime the observer moves through. Now you might think, okay, that's a nice theory, but can we actually test it? We can. We have multiple times. In 1971, Joseph Haffel and Richard Keating took cesium atomic clocks, the most precise timekeeping devices humans had ever built, and put them on commercial aircraft. They flew them around the world, eastward on some flights, westward on others. Then they brought them back and compared them to identical clocks that had stayed on the ground at the United States Naval Observatory. The clocks disagreed. The eastward flying clocks, which moved faster relative to Earth's surface, had ticked fewer times than the stationary clocks. The westward flying clocks, which moved slower relative to the rotating Earth, had ticked more. The differences were small nanoseconds, but they matched Einstein's predictions precisely. Time passed at a measurably different rate for clocks that move through space at different velocities. Now nancons might seem trivial. Who cares about nanoscons? You care about nancons. Every time you use GPS, you care about nanocons. Here's the thing about GPS satellites. They're moving at about 14,000 kilometers per hour, and they're way up there in orbit where gravity is weaker than at Earth's surface. Both of those things, the velocity and the weaker gravity, affect how fast time passes on the satellite. The velocity effect slows the satellite clocks down relative to ground clocks. The gravitational effect speeds them up because weaker gravity means faster time. The two effects don't cancel. Without relativistic corrections, corrections derived directly from Einstein's equations. GPS position calculations would drift by roughly 10 kilometers per day. 10 kilometers per day. Your phone wouldn't be able to tell you what street you're on. It would think you're in the next town over. The system that tells you where you are on Earth works only because the engineers who built it accounted for the fact that time runs at a different rate in orbit than it does on the ground. Relativity is not a theory awaiting confirmation. It is confirmed every single time you use a map on your phone. This fact that time is physical, that it bends, that it runs at different rates in different conditions is the foundation for everything that follows. And what follows changes what it means for something to be over. All right, follow the logic with me, but this is where it starts to get really strange. If time passes at different rates for different observers, if there's no single universal clock that everyone agrees on, then what is time? Here's the answer, and it's going to sound weird at first. Time is a dimension, not a metaphor for a dimension, an actual dimension, a coordinate, like the three spatial coordinates that specify where something is located. You need three numbers to say where something is in space. Up, down, left, right, forward, back. We call those X, Y, and Z, but you also need a fourth number to say when something is. We call that T. Space and time aren't separate things. They're woven together into a four-dimensional structure that physicists call spacetime. General relativity makes this explicit. Einstein's field equations describe the universe as a four-dimensional geometric object, a manifold in which matter and energy curve the geometry, and the geometry determines how matter and energy move. In this framework, events don't happen and then vanish into a gone past. Events exist at specific coordinates in the four-dimensional structure. Your birth is not an event that happened and disappeared. It exists at specific coordinates in spacetime, a particular location in space, a particular location in time, as real and as fixed as any other point in the four-dimensional structure. Your 10th birthday exists at its coordinates. Every conversation you have ever had exists at its coordinates. Every person you have ever loved exists at the coordinates where they were at every moment they were alive, at every location they occupied as permanently as any feature of the geometry. Hermann Weyl, one of the great mathematical physicists of the 20th century, said it with a precision that has never been improved. The objective world simply is. It does not happen. Only to the gaze of my consciousness crawling along the lifeline of my body does a section of the world come to life as a fleeting image in space which continuously changes in time. The world does not happen. It simply is the happening. The sense of events arriving and departing, of the present sliding forward along the time dimension, of the past receding, and the future approaching is what consciousness does as it moves through a structure that is itself static and complete. This is called the block universe, or eternalism. It's the most natural reading of general relativity. The interpretation that takes the geometry at face value without adding extra assumptions about which slice of the four-dimensional structure is the real one. Most physicists working in relativity take it seriously, not as a metaphor, not as a philosophical position adopted for convenience, as the literal implication of the geometry they use every day to predict gravitational waves, to calculate satellite orbits, to describe the curvature of spacetime around black holes. Now, think about what this means for a specific memory. I want you to actually do this. Think of a morning you sat at a kitchen table with someone you loved. The coffee, the light through the window, the sound of their voice saying something ordinary, something you didn't know you were memorizing at the time. That morning is not a ghost. It is not a fading trace in neural tissue in the block universe. That morning exists at its coordinates in the four-dimensional structure as physically real as this moment you're experiencing right now. The light through the window is still falling at those coordinates. The coffee is still warm, the voice is still speaking. You cannot reach those coordinates from here. Entropy has carried you forward and the geometry does not permit return. But the coordinates are occupied, the morning is there. I find this the most consequential implication of any physics result I have ever encountered because it says something specific about death. If the block universe is the correct description of reality, then a life that is ended has not disappeared. It has become fixed. A four-dimensional object in space-time, complete, extending from its first coordinate to its last, as permanent as any feature of the geometry. The person is not gone the way a fire goes out, extinguished, absent, nowhere. The person exists at every coordinate they ever occupied, at every moment they were alive, in a structure that does not delete what it contains. The universe does not erase the past. It moves forward in entropy, leaving the past exactly where it was. A human life in the block universe is a four-dimensional shape. It extends roughly 70 or 80 years along the time dimension, occupying a complex path through the spatial dimensions as the body moves through the world. The shape has a beginning. The shape has an end, but the end does not erase the shape. Think about a road. A road that ends at a cliff does not cease to exist behind you. The road is still there. Every mile of it, every curve, every stretch, you have reached the end of it. The road has not disappeared. A life is the same. The coordinates are occupied. The shape is complete. Death is the last coordinate, not the deletion of all the others. Gone from reach and gone from existence are not the same thing. That is the distinction Einstein was drawing in his letter to Besso's family. Besso had become unreachable. The present had moved beyond his coordinates. Entropy's arrow meant the living could not return to them, but the coordinates remained. The geometry had not changed. The structure that contained Besso's life had not collapsed or emptied. It was simply behind in the same sense that a city you drove away from is behind you on the road. Still there, still real, still populated with the events that happened in it, just no longer accessible from where you are now. You have experienced a small version of this already. Every place you have left, the house you grew up in, the town you moved away from, the room where something important happened that you will never enter again, those places still exist. The events that occurred in them feel gone because you have moved beyond them, because entropy has carried you forward and the distance grows. But the places are still at their coordinates on the Earth. The events are still at their coordinates in spacetime. You feel their absence because you are here and they are there. The absence is real. The non-existence is not. Relativity extends this from space to time. The past is a place you have traveled away from. It is behind you. It is not erased. Now, here's where it gets even stranger. Because we haven't talked about simultaneity yet, two observers in different states of motion disagree about which events are happening at the same time. There is no universal present, no single slice across the four-dimensional block that every observer agrees constitutes. Now, this is not a philosophical position. It is a measured consequence of the geometry. If you and I are moving relative to each other, the set of events you call simultaneous, the events you place in your present moment, is a different set than the events I call simultaneous. Your now and my now do not align. An observer moving away from Earth at a significant fraction of the speed of light would calculate that events decades in Earth's past are simultaneous with their present. For that observer at that velocity, what you experienced 30 years ago is happening now is part of their present moment, as real and as current as whatever they are doing at this instant. This is confirmed by the same physics that keeps muons alive. Muons are subatomic particles created in the upper atmosphere by cosmic rays. They're unstable. They should decay in microsecond suns. They should never reach Earth's surface. But they do reach Earth's surface in huge numbers because they're moving at nearly the speed of light and time runs slower for them. From our perspective, their clocks are ticking slower, so they survive long enough to reach us. From their perspective, the distance is contracted, so they don't have as far to travel. Their now is different from our now. Both are physically valid. The present is not universal, it is observer-dependent. And if the present is observer-dependent, then the past, the thing you have been assuming is gone, is someone else's present. The moments you cannot return to, the people who are no longer here, those exist in a universe where another observer's perspective makes them present tense. Your past is not erased, it is located. And from certain vantage points in space-amy, it is now. The loss is real, but the goneness is a matter of position, not of existence. All right, now, here's the obvious question. If the block universe is real, if the past exists as permanently as the present, then why does the past feel so completely gone? Why does loss feel like absence rather than distance? Why does death feel like deletion rather than separation? Why, when someone you love dies, does every cell in your body register it as a subtraction from the universe rather than a change in coordinates? The answer is thermodynamics. The answer is entropy. The answer is the way memory works. Memory exists because the brain records past states as physical changes to neural structure, synaptic weights, protein configurations, dendritic branching patterns. You remember the past and not the future because entropy means the past leaves traces and the future does not. A burned match leaves ash, a physical record of the fire that consumed it. An unburned match leaves no trace of the fire it will eventually become. An aging face records the passage of time in lines and texture and the accumulated marks of expression repeated across decades. A young face carries no record of the aging it will undergo. The traces all point backward because entropy's arrow points forward from order to disorder, from concentrated energy to dispersed energy, leaving records as it goes. That is why you remember yesterday and not tomorrow. That is why grief accumulates and anticipation dissolves. The arrow you feel is entropy's arrow, not a property of time itself. What you experience as the direction of time, that absolute conviction that the past is gone and the future is coming, is entropy's direction, not time's direction. The fundamental physics has no arrow. Entropy has one. And your consciousness, which is a physical process running on a brain that obeys thermodynamics, experiences entropy's arrow as the direction of time. The past feels gone because of how your brain interfaces with entropy, because memory works in one direction and not the other, because traces accumulate behind you and not ahead of you. The feeling is real, the gone it reports is not in, or at least it is not the whole story. The goneness is what it feels like to move through a structure that does not move with you. The structure stays, you travel. Loss aches partly because the world moves irreversibly forward in entropy. There are traces everywhere, new traces no longer forming. The photographs in a drawer, the handwriting on an envelope you cannot throw away, the chair they sat in that still holds the shape of how they sat, the recording of their voice on a phone you will never delete, the way a room still smells faintly of them weeks after they are gone. Entropy left these traces as it moved through the coordinates where the person was alive. Each trace is a record of a moment that existed, a physical imprint of a state the universe occupied at those coordinates. Now entropy has moved beyond those coordinates and no new traces are being laid down. No new photographs, no new handwriting, no new recordings. The accumulation has stopped and grief registers this as absence, as a person who is no longer here, who has been subtracted from the universe. But the physics says they have not been subtracted. They are still at their coordinates. Every moment of their life exists in the block, every morning, every conversation, every ordinary hour that neither of you thought to notice at the time. What has changed is not their existence. What has changed is your access. Entropy has carried you forward, and the distance between your current coordinates and theirs grows with every passing second. The gap feels like loss. The physics says it is distance. Now look, I have to be honest with you here because that's how physics works. You say what you know and you say what you don't know, and you don't pretend the boundaries aren't there. Eternalism, the full block universe, is the most natural reading of general relativity, but it is not the only interpretation physicists hold. Some defend a growing block model. The past is fixed, the future is genuinely open, and the present is the edge where new events get added to the structure. In this view, the past is real and permanent, but the future does not yet exist. Others defend presentism. Only the present moment exists, and the past and future are abstractions rather than real regions of spacetime. The debate is unresolved. Serious physicists hold each view. The evidence from relativity favors eternalism, but the question is not settled, and claiming it is settled would be the kind of premature certainty that has no place in honest science. But notice what even the growing block model says. The past is fixed. Even the interpretation that denies the reality of the future affirms the reality of the past. A life that has been lived in the growing block is permanently real, added to the structure, frozen at its coordinates, as fixed as stone. Only presentism denies this, and presentism has the hardest time accounting for the experimental evidence of relativity, where simultaneity is observer-dependent and the present is not universal. Across all interpretations, one thing is settled. Time is not what common sense assumes. It is not universal. It is not absolute. It does not flow at the same rate for everyone. It is not a river carrying events from past to future. It is a dimension measurably, confirmably to the precision of atomic clocks on aircraft and satellites in orbit. But here is the boundary, and it deserves respect. What the block universe cannot say is anything about experience. It describes the structure of events, their locations, their geometry, their permanence in the four-dimensional manifold. It does not describe what it is like to be inside those events, whether the you at past coordinates experiences anything, whether there is something it is like to be your past self at those locations, whether consciousness persists at fixed coordinates or exists only at the moving edge of entropy. These are questions physics does not have the tools to answer. It is the hard problem of consciousness wearing a space-time disguise. The block universe tells you the coordinates are occupied. It cannot tell you whether anyone is home. Here is the boundary, and it deserves the same respect as any boundary in physics. The physics goes as far as it goes and then stops. It says your life exists permanently in the structure of space-emy. It says death is a boundary in the time dimension, not an erasure from the structure. It says the past is as real as the present. And then it falls silent on the question that matters most, whether permanence in the structure carries experience or whether experience is something that only happens at the moving edge where entropy is active and the present is being lived. What physics offers is something precise, the permanent existence of every moment of your life in the structure of space-emy. Whether that matters, whether permanence without experience is meaningful, whether existence without access is consolation, depends on what you believe you are, a pattern of matter at coordinates, or the experience of being that pattern. Physics describes the pattern. It cannot yet describe the experience. But consider what the pattern contains. Every moment you have lived, the ones you remember and the ones you have forgotten, the ones that mattered and the ones that seem not to matter at all, exists at its coordinates. Your entire life is already written into the geometry, not in the future tense as something that will be preserved after you die, in the present tense as something that already exists as a complete four-dimensional shape in the structure of space-emy. You are not building a life that will one day become fixed. You are extending a shape that is already permanent at every coordinate you have already occupied. The past portion of your life is already in the block as fixed, as real, as permanent as anything in the universe. The question is only how far the shape extends before it reaches its final coordinate. Einstein wrote to Besso's family and reached for the only thing the physics he had spent his life building could offer. Not heaven, not reunion, not the promise that Besso was in a better place or that they would see him again. Just this. The distinction between past, present, and future is a stubbornly persistent illusion. Besso had become fixed, permanently located in the four-dimensional block, as real as any point in space, unreachable, but not absent. Einstein wrote the letter knowing he would follow soon. He was 76 and in declining health. 5 weeks later he did. And by the logic of his own physics, his coordinates in space-emy are as fixed and as permanent as Besso's. Both men exist in the block at their coordinates, at their moments, in a geometry that neither time nor entropy can erase. Those same equations that predict gravitational waves and correct GPS clocks describe a universe where the past does not disappear, where every ordinary morning of every ordinary life is written permanently into the geometry of what exists. Every conversation, every meal shared, every hand held, every unremarkable Tuesday that felt like nothing at the time, and now from the distance entropy has carried you feels like everything. All of it at its coordinates, all of it in the structure, none of it erased. Whether experience persists at those coordinates is a question physics has not answered. But the coordinates exist. The universe does not delete what has happened in it. It moves forward in entropy, leaving the past exactly where it was, exactly as real, exactly as present as it ever was. The people you have lost are at their coordinates, every moment of them, every version of them from the first day you knew them to the last. The mornings are still mornings. The conversations are still happening at their locations in the block. The laughter has not stopped. It is simply located at coordinates you have moved beyond, just behind you, now receding at the speed of entropy still.